All right, so we are in Unit 6. I know it should be Unit 5, but I changed my mind after I wrote the lessons over the summer. I'm kind of rearranging the order. So we're doing exponents. So this should be a review. We did exponents in 8th grade, so let's try and get through this quicker. We just spent weeks looking at different degreed equations, right? We had all these rational equations that then crossed the x-axis, and then we found out sometimes they had real roots and sometimes they had imaginary roots. And now we're going to go on to exponents and see what happens when we put unknown exponents in an equation. So if we look here, we go quickly. We got 2 to the 5th is 32, 2 to the 4th is 16, 2 to the 3rd is 8, 2 to the 2nd is 4, 2 to the 1st is 2, and 2 to the 0 power is 1. Hopefully you just saw a lot of patterns there. In fact, you should have saw 3 patterns. Well, the first pattern you should have seen is the obvious. They're all base 2. And then the next pattern you should have seen is that the exponents were going down by 1. And the last pattern you should have seen that to get from one answer to the next, you simply took half of the number above it. And that's because, well, shockingly, it was base 2. And then shockingly, you should have seen that 2 to the negative 1 is 1/2, not negative 1/2. And 2 to the negative 2 is 1/4, not negative. And 2 to the negative 3 is 1/8. And that's because we continue the pattern of taking half. And if the pattern were to go the other way, why, we would be doubling because we're increasing by multiplying by 2 every single time. So this is the review. It's negative exponents. So a negative exponent simply means to flip its place. If it's in the numerator, it goes to the denominator. So likewise, we can do this very quickly. If we start here with 4 to the 3rd, because we know 4 to the 3rd very quickly is 64. And then 4 to the 2nd is 16, which is 64 divided by 4. 4 to the 1st is 4. 4 to the 0 power is 1. So now we can see the pattern continue. We have to divide by 4. We have to divide by 4. We have to divide by 4. And hopefully you saw the last ultimate that 4 to the negative 3 is the same as 4 to the 3rd, except like we said, since there's a negative in the exponent, it reverses its position. All right, so we have our properties of exponents to remember. For all numbers x and y, as long as x and y don't equal 0, and their integers a and b, these are the following properties that should hold. Remember, when multiplying, we add exponents together. When we have a power raised to another power, we end up multiplying the exponents together. That's the shortcut. And really, this is still a power to a power, because these powers are really 1, and a times 1 is a. Here is that negative exponent. It means it simply flips into the denominator. When we're dividing, we subtract the exponents, and then this is really the power rule again right here. These are raised to the first power, so we simply have to raise the numerator and the denominator to the power, and anything to the 0 power is 1. So again, if I went through that very quickly, it's because it all should be review. So here's a couple of questions to review. Let's see. How do I like to do this? I like to do it one thing at a time. So for the first thing, I'm going to do the numerator. There's nothing wrong with the numerator. There's nothing I can do there. It stays x to the 8th, y to the 6th. Now I'm going to look at the denominator. Well, the denominator is telling me that it wants me to square everybody in those parentheses. And when we square a power to a power, that's what's happening here. We really just multiply. So x to the 3rd raised to the 2nd is really x to the 6th. And y to the 5th squared is y to the 10th. Now the next thing we have going on here is division. So we remember our division laws, which is to subtract the exponents. So this is really 8 to the x to the 8th, and then we minus 6. And then this is y to the 6 minus 10. That's what our brain should be thinking. So the answer is x squared y to the negative 4. Or we could have written it as x squared, and then knowing that this y to the negative 4 means that since it is a negative exponent, it switches its place from being in a numerator to being in a denominator. All right, number 2, if I look at this, first thing I see, all right, so I'm going to do the same thing. I'm going to look at the numerator first, and there is a lot going on in that numerator that I have to do. All right, so the first thing I have to do, nothing's happening with the 3, so that's coming over here. The x cubed is getting raised to the 4th power. Oh, power to a power means I multiply. That's not hard. Y to the negative 5, well, I could leave it there, but I'm going to practice the new rule that if the exponent is negative, it means to switch its spot. So y to the 5th is going to go down to the bottom, along with what's already in that bottom. Well, 3x to the 7th. Now I'm going to think that I have division left, so all I have to do is divide. Oh, I like this. 3 divided by 3 crosses off. The x to the 12th and the x to the 7th, if I remember, means I'm going to subtract their exponents. So that's going to leave me with an x to the 5th, and then in the denominator is a y to the 5th. Bring that over there. All right, so the next one. We have this fraction right here that we have to handle, and that doesn't look that hard. It's saying take this fraction here and raise everybody to the 5th power. Everybody in these deep parentheses has to get raised to the 5th power. That means this 2 has to get raised to the 5th power, which is 32. A cubed raised to the 5th power is a to the 15th, because a power to a power means multiply. A squared to the 5th power means a to the 10th. Now, could I have done that another way? Sure, I could have reduced inside the parentheses first, saying a cubed and a squared is really an a, and 2a to the 5th power is 32a to the 5th power, which is the same thing I get up top once I divide those fractions. Divide means subtracts those exponents. I get a to the 5th. Well, I'm not done yet, because they wanted me to multiply that by b squared raised to the 0 power, which we love because anything to the 0 power is 1. So regardless of what was in these parentheses, I'm going to raise it to the 0 power and get 1, so that means this is my final answer. Let's take a look at one more. Let's see, which one do I want to show you? I want to show you this one right here. This is saying take everybody here and raise it to the negative 2 power. Well, I'm going to do what I didn't do in the last one. I'm going to look what's happening inside first to see if I can clean that up. And what I see here, I see z cubed divided by z to the first. So my brain should go, well, z cubed minus a negative 1 makes that z to the 4th. So what I have here is a z to the 4th over a 5. But all of that still has to get raised to the negative 2 power. I'm going to do each one individually. I'm going to take z to the 4th and raise it to the negative 2 power. A power to a power means multiply, so I get z to the negative 8th. Then I'm going to do my denominator, 5 to the negative 2. Well, 5 to the negative 2 means 5 squared, 25, and then flip that and I get 1 over 25. Now, I can't leave the answer like that. It's improper. We have a fraction that contains a fraction. So we know that when we have a fraction on the bottom, we divide by it, which ends up being multiplying, and we get 25. Z to the negative 8th then switches its place because it's a negative exponent. So in a way, this 5 to the negative 2 we knew was going to flip up to the top because it's a negative exponent. All right, so tomorrow in class, we're actually going to do quite a bit of work here. We've got these 3 problems that we want to work on because this is really what Common Core wants you to do with exponents. They want you to understand the laws and apply them to the next level of thinking. These questions that we just did are supposed to be pretty easy. All right, see you tomorrow.